in this exercise, we are going to implement the first version of the shooting game. So in this game, we'll primarily concentrate on learning about designing the graphics and the movement on the screen. So in this exercise, as you can see, you have these little Android guys falling down from the top, and we have a cannon at the bottom, which we're going to make use of to shoot down the Android guys as they fall down. So this is a typical shooting game exercise that you might have seen in many different contexts. This is just an attempt at using that idea for our shooting game exercise. So we can move the cannon left or right and then shoot bullets at the falling Android guys. So the left and right arrows can be used for movement, and then use the middle button to shoot the actual cannon at the shooting guy. You can use the thin blue line as a guide to position it. Obviously, if you're playing on a real device, the speed of moving the cannon would be much more pleasanter than in the emulator, but it's a good fun way of learning certain aspects about graphics in Android. To get you started on this exercise, as usual, go to the course site and then download shootinggame.zip file that we have provided for you, and then import the project into Android Studio. And as usual, we have pre-configured some parts of the project to get you started very quickly. Now, parts of this implementation are based on the basic graphics example that you have already seen earlier. So we still see the use of the custom view, which is the draw view. And we still are going to make use of the different drawings that we had done earlier, except now that certain parts of what we are drawing on the user interface, I have moved them into separate classes so that it's more easier to manage changes to certain properties of each of those objects in their own individual class. So first and foremost, when you visit the layout, you would notice that the layout is very much similar to what you have seen in the basic graphics example. So if you look at the text view, you would see, in addition, I have 3 buttons, image buttons, that I have included at the bottom. So you see the 3 image buttons here, the left, right, and the shoot button here. I have included their corresponding graphics images into the drawables folder at different resolution levels. And I have put these 3 into a horizontal linear layout here. The white part of the screen is occupied by the draw view custom class, and it is in there that we're going to draw all the action part of the game. In response to the clicking of the buttons, we'll do certain changes to the user interface. Let's get started and then examine some of the code part of this exercise next. Getting back to the user interface again, you see me still using the toolbar and other aspects that we have already studied, and also the use of the colors by using the color palette and so on, which we have already seen in the previous exercise. So I'm just continuing to use those features in this example. Now let's go and visit each one of those classes that we have for this exercise in more detail. First, let's examine shootinggame.java. This is the single activity that is driving the entire application. So this is a extension of the AppCompat activity. So we have seen why we are extending the AppCompat activity earlier. And in here, since we have buttons on the screen, so we are going to use the onClick listener for these. And when you come into the onCreate method, you would see the standard structure here. So I have all the buttons being declared here and getting references to those buttons, and then setting up the on-click listener for each of those buttons in here. Going down into the on-click method, you see me implementing the on-click method using the switch statement, just like what we have done earlier. Now the interesting thing for you to notice is that when you have multiple buttons being handled by the same on-click method, we are going to take advantage of the availability of the ID of the button in order to select which button has been clicked, and then appropriately execute that part of the switch statement. So and for each one of them, I'm going to call the methods in my drawView class, which are going to implement those functionalities for me. So this is a quick overview of the shooting game. Spend a little bit of time looking at the code. As always, we have documentation in the code, so it is a good idea for you to read all the comments that we have written in the code. Now, the drawview.java file. So we're briefly going to visit the drawview.java file in order for me to point out certain aspects. Then we will go and visit each one of the other classes that I have implemented in this exercise, and then come back to drawview.java to see how exactly we implemented the actual game and make some modifications to it to activate the game playing. Now in the drawview.java file, you see that I have created a Canon object and the Android guy object, and then also created array lists for bullets and explosions. We'll see how we're going to make use of them later on. But what this suggests is that now I am storing each one of these different kinds of items that I draw on the screen as separate objects, so that I can easily manipulate their properties independently. So let's visit some of these classes to understand what exactly is being done in each one of those classes. We'll begin our journey with Canon class. The Canon class handles the drawing of the cannon on the screen, and also tracks the position of the cannon. So for example, if you use the buttons to move the cannon left or right, this class takes care of implementing or ensuring that the movement is appropriately handled. Now let's go in. This pattern that you see in the Canon class, I am using the same pattern for the remaining classes of objects that I create. So it's interesting to examine one of them in more detail to understand how it all works. So the Canon class basically contains an XY position of the cannon, the current XY position of the cannon, and also provides me with a step direction. So if I move the cannon left or right in by clicking the buttons, the cannon is moved to left or right by that step value. So this provides me with movement of items on the screen. And then also I have the bounds for where the cannon can move. So this indicates the size of the screen for me. Now for the cannon, the constrained movement is only along the X direction. There is no movement along the Y direction for the cannon, because it doesn't make sense for the cannon to be moving up and down. Instead, it is moving at the bottom of the screen to the left or the right side, depending on when the left or the right button is clicked. So the movement of the cannon is handled by the move left and the move right methods that I have implemented here. In each one of these methods, every time the move button is clicked, the cannon is going to be moved left or right by 15 units. I have randomly selected 15. You can always change that. That value determines how fast your cannon responds when you move with the buttons. So that can be adjusted as required. And also I ensure that when the cannon hits the right boundary or the left boundary of the screen, it just doesn't fall off the screen. Instead, it'll be stuck there until I start moving it in the other direction. In addition, every one of these methods, every one of these classes will have a draw method associated with it. So whenever I need to draw the cannon on the screen, I'm going to call this draw method, and this draw method will implement the drawing on the canvas of the cannon. Now that we have examined the cannon class, let's pay a brief visit to the Android Guy class. This is the class that handles the drawing of the Android Guy on the screen. Now, as you noticed from the game itself, the Android Guy is moving vertically downwards all the time, and I need to track the X and Y position of the Android Guy. So this X and Y position tracks the top left corner of the Android Guy's image and the step value. Now here I have included both step X and step Y. At this moment, I'm moving the Android Guy only in the vertical direction, so I'm going to ignore the step X. But in case you're implementing a game where you have objects moving both in the horizontal and vertical direction, you can take advantage of both of these to implement the appropriate movement. This all comes down to how you implement your game physics. If you are implementing a very comprehensive game, then you need to implement what we call as the game physics, which involves movement of items, and then you will have to simulate the movement of items following the standard natural laws of motion. You must have all studied Newton's laws of motion in your high school. So all those come into play. But then we are not going to that level of detail in this game. We are preserving it to be very simple movement. It is a constant velocity movement along a given direction. So that's why our equations are fairly simple. The physics equations are fairly simple in this game. So in addition, you would see that I have the methods for moving the Android Guy. And in this case, this move method basically moves the Android Guy vertically downwards by one step at a time. And then I have the draw method as such, which draws the Android Guy onto the canvas. And sometimes when the Android Guy hits the bottom of the screen, I'm going to remove that and recreate another Android Guy to start falling from the top, and that is implemented by using the reset method here, and so on. Now, in addition, I have the bullet class. The bullet class is the one that handles the whenever the cannon is shot, a bullet is created and the bullet starts moving vertically upwards. So this is similar to the Android Guy, except the movement is in vertically in the vertical direction, but in the upward movement. So this is implemented. Again, you see the use of the move and the draw methods here, and then the use of the XY coordinates, and then the step, and so on. So as I said, all these different objects, they implement very common patterns there in the code. So that's why if you understand one in more detail, the rest of them are fairly easy to follow. So in the game screen, we could have multiple bullets simultaneously moving in the upward direction. So that's why I create an array list of bullets, keeping track of several bullets that might be simultaneously on the screen. Now, obviously, you wouldn't have more than 4 or 5 of these on the screen at any given time. No human being can play faster than that anyway. Finally, the last one that we will see is the explosion.java file. The explosion class draws the explosion on the screen when an Android Guy is hit by a bullet. So what happens is that when the Android Guy is hit by a bullet, we will remove both the Android Guy and the bullet from the screen, and then replace that with an explosion image for a short duration, in this case about 1 second, so that it sort of gives a visual indication as if the collision between the Android Guy and the bullet has generated an explosion at that point. So this explosion image is drawn at a fixed location on the screen, the exact location where the collision occurred between the Android guy and the bullet, and it'll remain static at that point for about a second before being discarded from the screen. So these are all the various other classes that I have set up to help me with the DrawView class. Finally, coming back to the DrawView class, let's quickly examine the code here. In this code, you see that in the constructor of the DrawView class, I am creating a Canon and an Android guy, and then I'm creating array lists for bullets and explosions. Remember that the bullets and explosions will be created on the fly whenever the user shoots the Canon or when the bullet hits the Android guy. So these would be dynamically created, whereas the Android guy and the Canon would be more on the screen most of the time. Now, the actual drawing of the screen, so let's examine that in more detail. We are taking advantage of the availability of the onDraw method for our view. So I'm going to use the onDraw method in order to draw the items on the screen. So in the onDraw method, I will be using this other method called drawGameBoard, which is where I'm going to construct the game board and drawing all the different objects onto the screen before displaying it to the user. Now, how does the game actually work in practice? Now, if you are familiar with creating animations on the screen, basically the way we implement the game is that the motion is created by displacing the objects little by little on the screen and then redrawing the screen at regular intervals so that to the human eye it appears as if it's continuous motion. Now, this is where we take advantage of the human vision. If you recall from your high school physics, the eye can detect continuous motion if you are going to display at a rate greater than 24 frames per second. So this is exactly what is used to our advantage in motion pictures, in video, and in many other aspects. So essentially you're drawing frame by frame at a fast enough rate that the human eye thinks that it is continuous motion. We are exactly using the same principle here in this game. So what I am doing here is that I will draw a game board, then I will make my game sleep, my thread sleep for about 30 milliseconds. Now, getting into threads and so on gets a little bit overboard at this point, but believe me that this is a way that you can implement. If you know how Java threads work, then you will understand this part. Even otherwise, it's not of much consequence to us. All that we are trying to do is every 30 milliseconds, we're going to redraw the screen. And every time we redraw the screen, we're going to move the objects a little bit so that to the human eye, it appears to be continuous motion. Now, once we draw the game board and then display it on the screen, then we're going to wait for about 30 milliseconds. Then we're going to call this method called invalidate. Whenever I call the method called invalidate, this will be a method call into the Android framework. When Android framework receives this invalidate call, then it is going to come back and redraw the screen for me. At that point, it is going to call the onDraw method again in order to redraw the screen. And when it calls the onDraw method again, I would redraw the screen, but with the objects slightly displaced from their previous location. And then every call to the onDraw method will again result in a call to the invalidate method. And this will again force the Android framework to come back and redraw the screen. So this continuous cycle of calls to the onDraw and the invalidate is what generates the motion on the screen. So now that we have understood a little bit about how this all works, let's go and examine the drawGameBoard method itself. In the drawGameBoard method, as you come down, you would notice that I have left a few blanks for you to fill in. So this is what we're going to do in this exercise. fill in each one of these to-do comments with the appropriate code. As we have seen already, each one of those objects, the Canon, Android Guy, and so on, has this draw method implemented in there, and that draw method is going to be used by us to draw the items on the screen. So to draw the Canon, for example, I am going to call the draw method of the Canon class and pass the canvas as a parameter, and so this is essentially asking the Canon object to draw itself onto the canvas. For all the bullets on the screen, since we have multiple bullets and these bullets are being tracked by the array list that we have, so I am going to replace the to-do with a for loop that runs around the bullets array list and then draws all the bullets onto the screen one by one. So essentially it's going to, for each one of the bullets, it's going to ask the bullet object corresponding to that particular bullet to draw itself onto the canvas. And if it happens that the bullet goes beyond the top edge of the screen, that bullet is going to be removed from the array list. So this is the for loop that implements the drawing of all the bullets on the screen. I am using the same procedure for drawing all the explosion images onto the screen. So here I am looping over the explosion array list, and then for each one of the explosions object in the array list, I am going to draw it onto the screen, and if the explosions object has to be deleted, then I'm going to delete it from the screen. So the explosion object is displayed on the screen for about a second, and then it'll be removed from the array list. And finally, for all for the Android Guy, I'm going to track and see if the Android Guy exists on the screen, and then we will draw the Android Guy on the screen. Now, as the Android Guy is falling down, if the Android Guy is hit by a bullet, I need to replace that Android Guy by a explosion. So this is what is implemented by this inner for loop here. Inside this inner for loop, for all the bullets, this is a very straightforward, simple way of checking for collisions between the Android Guy and the bullet. So for the Android Guy, I'm going to go through all the list of bullets that are in the array list, and for each one of them I will cross-check to see if it so happens that the bullet's current position intersects with the position of the Android Guy. If they do, then it is a hit, and so I'm going to replace both the Android Guy and the bullet. I'm going to remove them and then replace them with an explosion. So that is essentially what I am doing here using this if loop. So I'm checking for in Android case, if you have two objects, then I can construct rectangles around those objects and then check for intersection between two rectangles by using this method called intersects method that is available for my objects. So I'm comparing the rectangle around the Android Guy and the rectangle around the bullet and checking to see if the two intersect with each other. So if they intersect, then that means that it is a collision between the two, and then so at that point I'm going to replace that point by an explosion object, and then I'm going to reset the Android Guy to again start falling from the top, and then I'm going to remove that particular bullet, and so the explosion object will be created and inserted at the point of collision between the Android Guy and the bullet. And then I move the Android Guy and then continue on with that exercise. So these three modifications enable us to ensure that I'm drawing the game board every single time. Every single time after I draw the game board, then I move the objects a little bit from their previous position, so that the next time around when I come to draw them again, the objects will be in their new positions. So with this, we complete the first version of the shooting game exercise. Let's go ahead and then run this example and see it running on the screen. So when you finally see the application running on the screen, you can start playing the game at that point, and you notice how we are using the buttons to move the cannon and then shoot the android guys. So have some fun playing this game for a while. You can now start thinking about how you're going to modify this game with some more features. So as we go through in the next set of exercises, we're going to introduce some sound features and also keeping track of our score as we shoot down the android guys.